Could you guess how many grains of sand are in this beach? Well, maybe the whole beach is a bit too big to gauge. Let's say this handful of sand. Fine sand grains, all more or less uniform in size, are produced from larger rocks through ages of jostling and rubbing, driven through waves and weather by the distant moon and sun. The beach is much like space. Well, maybe excluding the fact that space is completely silent. A handful of sand contains about 100,000 grains, which is more than the number of stars we can see with the naked eye on a clear night. But the number of stars we can see is only the tiniest fraction of the number of stars that are. What we observe at night is the merest smidgen of the stars closest to us. Meanwhile, the cosmos is rich beyond measure. The total number of stars in the universe is greater than all the grains of sand on all the beaches of the planet Earth. I love the way the Earth rotates. It really makes my day. The sheer size of space makes it impossible to accurately predict just how many stars we have. Right now, scientists and astronomers use the number of stars only within our galaxy, the Milky Way, to estimate. That number is between 200 and 400 billion stars, and there are estimated to be billions of galaxies, so the stars in space really are completely uncountable. The great majority of these stars have lifetimes of billions or more years in which they are shining stably. Well, if any of you have a burning passion to visit this magnificent ocean of stars, you may want to know that space fashion is quite the costly business. A full NASA spacesuit costs $12 million. 70% of that cost is for the backpack and control module. But maybe it's quite worth it, knowing that there may be a planet made out of diamonds out there. Research by Yale University scientists suggests that a rocky planet called 55 Cancri E, which has a radius twice Earth's and a mass 8 times greater, may have a surface made up of graphite and diamond. It's 40 light years away, but visible to the naked eye in the constellation of Cancer. While mining for girls' best friends, keep in mind that smithing your new out-of-this-world ring may be easier done in space as well. If two pieces of the same type of metal touch in space, they will permanently bond. This incredible fact is also known as cold welding, and it happens because the atoms of two pieces of metal have no way of knowing they are separate. This doesn't happen on Earth because of the air and water found between the pieces. If you're the type for lifelong commitment and making a permanent change on Earth, well, I can't really help you there. But if your space tour includes the moon, you may just be able to leave a long-lasting souvenir. A pretty impressive "I was here" mark, if you will. The moon has no atmosphere, which means there is no wind to erode the surface and no water to wash footprints away. This means the footprints of the Apollo astronauts, along with spacecraft prints, rover prints, and discarded material, will be there for millions of years. Our local group of galaxies is dominated by two large spiral galaxies, the Milky Way, which harbors our solar system, and the Andromeda Galaxy. Which of these two is larger depends on which measure you use. The diameter of the Andromeda is about twice that of the Milky Way, but the Milky Way is much denser and turns out to have a larger mass. The Andromeda Galaxy is also approaching the Milky Way, where our solar system is, at a rate of around 110 kilometers per second, and eventually the two will collide to form a giant elliptical galaxy called the Milkomeda. Creative name, that one. To say the universe is awe-inspiring is the understatement of the century. But with all of its bewildering characteristics and frankly mysteriously terrifying implications, My interest in the cosmos is one deeply rooted in philosophy. Maybe space can tell us something about ourselves. In the words of one of my most beloved philosophers, Alan Watts, it's like you took a bottle of ink and you threw it at a wall. Smash! And all that ink spread.
And in the middle, it's dense, isn't it?
Isn't it?
And as it gets out on the edge, the little droplets are finer and finer and make more complicated patterns. See? So in the same way, there was a big bang in the beginning of things, and it spread. And you and I, sitting here in this room, as complicated human beings, are way, way out on the fringe of that bang. We're the complicated little patterns on the end of it. Very interesting. But so we define ourselves as being only that. If you think that you are only inside your skin, you define yourself as one very complicated little curlicue, way out on the edge of that explosion, way out in space and way out in time. Billions of years ago, you were a big bang, but now you're a complicated human being. And then we cut ourselves off like this and don't feel that we're still the big bang. But you are. You are actually, if this is the way things started, if there was a big bang in the beginning, you're not something that is a result of the big bang on the end of the process. You are still the process. You are the big bang, the original force of the universe coming on as whoever you are. See, when I meet you, I see not just what you define yourself as, Mr. So-and-so, Miss So-and-so, Mrs. So-and-so. I see every one of you as the primordial energy of the universe coming on at me in this particular way. I know I'm that too. But we've learned to define ourselves as separate from it.